so this time we're going to have the different multiplicities on here, right? We have a polynomial of degree 5, so we know we should have 5 zeros. We have a root, let's see here, of negative 1/2, so x minus negative 1/2 with a multiplicity of 2, so we've got that one. 0, so x minus 0 with a root of multiplicity 1, so we've got that. And 1 as a 0 of multiplicity 2. All right, so what do we know about what the graph's going to look like? We can do this real quick. We can say, well, okay, we've got our root, we've got our multiplicity, and then we've got the question of, is it going to cross the x-axis or just touch? Right, so we've got our root at negative 1/2, multiplicity 2, even multiplicity, we know it's going to touch. We've got a root of 0, multiplicity 1, we know it's going to cross. And a root of 1, multiplicity 2, we know it's going to touch. It's degree 5, so we know, barring another point given on the graph besides the x-intercepts, we're going to assume positive, right? So we've got what? We've got negative, let's put the here, negative 1/2, 0, you know what, let's spread this out a little bit. Here, negative 1, positive 1. So we know we have a root there, we know we have a root 0, we know we have a root at 1/2, and so we know the 1/2 is going to touch. We know the at 1 it's going to cross, at 0 is going to cross, and we know at 1 it's going to touch. So roughly speaking, we're looking like this for our graph. Okay. So for any polynomial function with real coefficients, I've said this already, but here it is in writing. Imaginary zeros always occur in complex conjugate pairs. So if you know, for instance, that 1 plus 2i, if 1 plus 2i is a root, then 1 minus 2i is also a root. And we have to have that because otherwise we would have some coefficients that were imaginary, and we don't want that. And the same thing goes for polynomial functions with rational coefficients. If you have an irrational root, like a square root or cube root or whatever, they're going to occur in conjugate pairs. So if we have, let's say, 3 minus root 5 as a root, then 3 plus root 5 is also a root. So we can use that to say, hey, if I say I got a polynomial of degree 3, and I tell you some of the roots, but not all of the roots, we know enough to provide the rest of the roots, though, right? Because we know degree 3, so we know it will have 3 roots. So we've got negative 5, we've got root 3, and we know the other one has to be negative root 3 because those are our conjugate pairs. So we have x minus negative 5, we've got x minus root 3, and we've got x minus negative root 3. Now usually, we don't really like to have irrational numbers in here, so we will usually FOIL these out and have it become x squared minus 30. And then down on this next one, we have 2 and I given, so we know negative I also must be a root. So we've got x minus 2, x minus I, and x minus negative I. But again, we don't like to have complex numbers in our final answers, so we will multiply those out. And we're going to get x squared, and of course this is sum and a difference. So the inside and outside terms are going to cancel, and we're going to have minus I squared, which is minus negative 1, so plus 1. And that is a good place to stop for now.